đậu trời lên đâm 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 đậu ơi.
Okay. So last time we derived this coordinate transformation. So we derived these coordinate transformations and its inverse transformation, right? So we have uh, coordinate transformation. We know this one. The xi prime is equal to summation of the direction cosine ij x j. Okay, and we also know how to transform from primes to unprime coordinates. We call this one as the inverse transformation of this equation. We know that x I, the inverse transformation, we know that xi is equal to summation of, mm, I think this is j. Yeah, this is j. So we have j lambda ji x j j prime. Okay, so these are the coordinate transformations if you want to transform from one coordinate transformation to one coordinate system to another coordinate system. Now let's now go to in the book of Marion. After this topic is natay some backgrounds about a matrix. Okay, so nasa book of Marion katong matrix operations, how will you multiply matrix, but skip lang sa nato to because I think tackle to ninyo siya sa mathematical physics or yeah sa mathematical physics. So skip sa nato to gamay para matakol na to tong after that. The next topic for matrix sa book of Marion, ha, sa book of Marion is kaning um, vectors na dayon, no? So itong dot product, triple product, and so on. So I will skip the topic for matrix. Kung gusto po mo mabasa, pwede ra gyapon. Pwede ra nito basahon ang katong about matrix, about uh, uh, multiplying matrix. There are laws how to multiply, how to get the inverse of the matrix. So basically nana sa math figure, no? Makuha niyo o matakol niya sa math fee. So skip sa nako to. Kung napatay time, pwede to sa balikan. Okay? So let's now go to this topic. Definition of a scalar. We know this one. Ang how to define scalar and a vector. Okay? In terms of transformation properties. In terms of transformation properties. Okay. So we know the coordinate transformations given by this, katong x prime, xi prime equals summation of direction cosines and so on. So we have this. We have these coordinate transformations. Okay. J lambda ij xj with this definition, we will define another or I will introduce another symbol. I think familiar na gyapon sa inyo nga symbol. We call this one as Kronecker delta symbol. Kung kadumdum mo ani sa I think tani siya sa math fee. We have this lambda ij lambda k j this is equal to Kronecker delta ik. So by definition of Kronecker delta, we have this expression again, the delta ik, okay, where delta ik is called the Kronecker delta symbol. Okay? So what do you mean by this? Si Kronecker delta, kay na lang actually duha lang ka values na ako it's either 0 or 1. Okay? So kano sa siya mag 0, kano sa po siya mag 1, 0 delta ik can be 0 or can be 1. So nasa do ka value, no? So duha yang value 0 or 1. Kano sa sama 1 if the index I is equal to k and 0 siya when I is not equal to k. Okay, nakuha. So take note, ik are just dummy variables or dummy indices. So when you say when you say when I is equal to k, then this symbol Kronecker delta is equal to 1. So duha lang yung value, no? 1 or 0 lang. So when kung ako ingani delta 1 1, this is equal to 1. Delta 1 2 is equal to 0. Delta 2 3 is also equal to 0. So as long as dili parehas ang indices, then the Kronecker delta symbol is equal to 0. Okay? And I think based from this definition, kung kadong kakontaan no, na koy lambda ij lambda kj is equal to delta ik. Okay? So when we expand this one, ang tao na to, no? We know the direction cosines lambda 1 1 1 2 1 3 and so on and so on in 2 dimension. Let's prove that this is correct. Okay, i-prove na to nga correct ni siyang kini siyang equation. In 2 dimension, if we expand this one, expand na ko ni, no? Expand na ko ni siya, I have say when j is equal to 2 for example. Okay, when j is equal to 2 for example, not j but I and k. Ang tao na to, ha? When I is equal to 1 and k is equal to 2. So kabalo ko, yung kaning summation must be equal to 0 because I is not equal to k. Tama? So when I is equal to 1 and k is equal to 2, then this summation becomes, we have lambda 1 1, lambda 2 1, in 2 dimension lang sa, no? Plus lambda 1 2, lambda 2 2. Okay, tama ba? Na ako'y your j runs from 1 to 2. Okay, j runs from 1 to 2. Okay, runs from 1 to 2. Okay, so we have lambda 1 1. Tama ba? When I is equal to 1, k is equal to 2. Wala dili summation ang I ug k, ha. Ang imo lagi sum is na koy j lang. Okay, so this is in 2 dimensions, so do lang ka terms ako makuha. So na koy lambda 1 1, lambda 2 1 plus lambda 1 2, lambda 2 2. And we know lambda 1 1, I think this is cosine theta. Aba, cosine theta ba ni? Yeah. Wait. Yeah, it's lambda, it's cosine theta. And then the lambda 2 1 is minus sine theta. Minus sine theta. Plus the lambda 1 2, it's sine of theta. Plus lambda 2 2, it's cosine of theta. So as you notice, if you add this one, this is equal to 0. Okay? Because your I is not equal to k. So therefore, this summation must be equal to 0. By definition of Kronecker delta symbol, Kronecker delta ik, when I is not equal to k, then this summation must be equal to 0. Now, when I is equal to 1, also k is equal to 1. Nandito na to, no? When I is equal to 1, k is equal to 1, what will happen is, na ako'y summation nga lambda 1, 1, lambda j 1, 1 pod plus lambda 1, 2, lambda 1, 2. Tama? Lambda 1, 2, lambda 1, 2. So na ako'y lambda 1, 1 is cosine theta. Multiply mo sabay cosine theta. Excuse ah. Okay? Plus the 1, 2. 1, 2 is sine of theta. Lambda 1, 2 is also sine of theta. So this one is cosine square of theta plus sine square of theta. Then this is equal to 1. So muna ang definition sa Kronecker delta, no? So when I is equal to k, this one, when I is equal to k, then this summation must be equal to 1. Okay? So 0 1 lagi na ang imong makuha nga answer. Okay? So we define that one, that Kronecker delta. Next is we actually call this one as the orthogonality condition. Orthogonality condition. Okay, and it has something to do with the perpendicularities between two vectors. Kung kadumdum ta sa ato physics 41, kung yung orthogonal, it means that the two they are actually perpendicular to each other. Okay, so when you say orthogonal, kabalo kung there are the two vectors are mutually perpendicular. Okay, so we call this one as orthogonality condition. The coordinate axis, it means that the coordinate axis in each of the systems are mutually perpendicular. Okay, so may orthogonal, mutually perpendicular. Okay, so this is the condition for orthogonality. Now, we also define scalar. Scalar is unaffected or invariant under such transformation. So I will define, say, phi as scalar, and we know the definition of a scalar. Scalar is invariant under coordinate transformation. So it is invariant under coordinate transformation. So later we will prove how to prove that the function is a scalar using kaning concept of coordinate transformation. Now, scalar is invariant, but vector vector will change under coordinate transformation. So I will define. So this is just a definition of these two, scalar and a vector quantity. So a set of quantities, I call this one as A. We will not, sometimes sa 41, mugamit ta og arrowhead, and we call this one as a vector quantity. Okay, so consider this as a vector, and it has in three dimension, it has three components, right? We call this one a set of quantities. If a set of quantities A, which has a components of A1, A2, and A3. Okay, take note ha, nag-change sa notation ha. Instead of using AX, AY, and AZ, we will use components or a set of quantities like A1, A2, and A3. Take note, para di ta maglibog ha. Why is it nga himo na ko siya A1, A2, A3? It's because para later, sayon ra siya himuon or sayon ra siya i-form into a summation notation. Okay? But take note, if you recall sa 41, okay, if you recall sa 41, AX, A1 is AX, A2 is AY, and A3 is AZ. Okay, so take note of that. So this is a set of quantities, and this quantity we call this one as vector. Okay? Usahay din anak butangan siya og araw, take note ha. Usahay din anak sa butang araw. So if a set of quantities is transformed under coordinate transformation, then this one is a a vector quantities. Okay? If a set of quantities is transformed under coordinate transformations, under coordinate transformations. Okay, we know this equation, and if we use the term or the quantity A, we have this equation for coordinate transformations. A I prime is equal to summation of lambda ij aj. Sakto ba? Instead of using x, ang gamit na ko is a because I defined a set of quantities which is kaning a1, a2, and a3 as a vector quantity. Okay? So if it is transformed under coordinate transformation, then this quantity is called a vector quantity. This quantity is a vector quantity. Okay? So if it is transformed under coordinate transformation with some equation given by this, take note ha, para sa ano, itong x, instead of x lang ako gamiton, a lang ako gamiton because my notation for a vector is denoted by this letter A. Okay? So kato lang, scalar, it will not transform, it will not, it is invariant, and vector is transform under coordinate transformation. We also have these vector operations, okay? I think natakol na ninyo ni sa electromag, pero lahi lang ang gamit na to nga set of notations, okay? We use not AX, AY, AZ, but A1, A2, A3. Nakuha. So, if instead of using AX, AY, AZ, tama ba kani? Kung kadumdum mo sa inyong electromag, instead of using AX, I hat, AY, J hat, AZ, K hat, we will now use, in this subject, we will use A1, A1, E1 plus A2, E2 plus A3, E3. Okay? Where A1, A2, A3 are the components of my vector, and E1 where E1, E2, E3 are called unit vectors. Okay? Take note, are called unit vectors. So instead of using I hat, J hat, K hat, we will use unit vector as E1, E2, and E3. Take note ha? Take note of that because magamit naman sa later kaning E1, E2, and E3. E3. Okay. So we have vector operations. We can add vectors. We can add vectors. AI plus BI. Okay. Which is equal to BI. So na ko'y property, we call this one as commutative commutative property. Pwede mo siya interchange, okay? For addition nga operation. We also have associative. We have AI plus BI plus CI. You can write this as AI plus BI plus CI. So we call this one as associative property. Okay? And then for multiplication, we have multiplication by a scalar. So we call this one a scalar multiplication. Scalar, say, this is epsilon. And my vector is A. Okay. So this one, if you multiply a scalar epsilon times the vector A, this is the resulting vector is also a vector. say I call this one as B, okay, which is a vector, okay. So kung scalar multiplication lang imong multiply, then ang makuha nimo nga result is also another vector, which I call that one as B. When we have two scalar function, epsilon and phi, the result is some another scalar function, psi. This one is a scalar vector. Okay, so when you multiply a scalar to a vector, then the resulting quantity is also a vector. When you multiply two scalar, say the epsilon and the phi, the resulting quantity is also a scalar. So how will you prove? Oh yeah, that one scalar. Now we also have this. This is scalar multiplication. Next is we have this scalar product. It is commonly known as the dot product. Okay, dot product. So when you multiply two vectors, natay duha ka klase, no? Scalar product and the vector product. The dot product and the cross product. Okay. So scalar product is defined as this. If I have two vectors, A, and then I dot this one to another vector B, then this is actually equal to summation of AI, BI. Okay? Sakto ba? Sa inyohang sa ato ang physics 41, this is the definition of a scalar product. So that is why nigamit ko A1, A2, A3 kay kung if you recall in your physics 41, if I dot A and B, ang makuha na ko is actually AX, BX. Kung magamit ko AX, AY, AC, no? Plus AY, BY, plus AZ, BZ. Sakto? But if I use A1, A2, A3, okay, if I use A1, A2, A3, na ko'y A1, B1 plus A2, B2 plus A3, B3. And this one can be written in summation notation, which is equal to the summation of AI's, BI's, where I runs from 1 to 3 in 3 dimension. Okay? That is why gamit ko 1, 2, 3 para masulat na ko siya into a summation notation. Take note of that. Take note the definition of a scalar product, because later when we prove a triple scalar product later using Levi-Civita, gamit kayo or dapat kabaluta nga that product is equal to this summation of, take note ha, mag-summation na tatanan later, okay, summation na tatanan para di mo maglibog ha. That product is equal to this one, AI's BI, a summation of AI BI, where I runs from 1 to 3. Now, scalar product, ang resulting quantity niya is scalar. Okay? Take note, gitawag siya nga scalar product because kung i-dot product nimo ang duha ka vectors, ang makuha nimo is just a scalar quantity. And take note, we defined scalar as invariant under coordinate transformation. So how are we going to prove that the resulting quantity of a scalar product is a scalar? So lantaw na to, no? Proof. A dot B is a scalar quantity. Tanaw na to ha. Proving that A dot B is a scalar quantity by proving that A dot B must be equal to A prime dot B prime. Ano kay to? Kay dapat equal lang ang duha ka ni nga quantity under coordinate transformation para ma-prove nimo nga scalar quantity siya, tama ba? So para ma-prove na to nga scalar quantity siya, we must prove that A dot B must be equal to A prime ang iyahang transformation dot B prime. Okay? So how will prove that A dot B is equal to A prime dot B prime? So this is invariant, no? Invariant. Dili dapat siya mag-change. Okay. We have this. We know this one. Proof. Solution. We know this one, no? A prime is equal to summation of j lambda ij aj. Okay? For b, na ako'y b prime equal to summation of j. Ano, not j but nagamit ang tag j, no? Gamit ang tag k. Gamit ang tag k. Lambda ik b bk. Okay? bk. Take note, ijk's are dummy indices. So we will define the coordinate transformation of a prime and b prime equal to this one. Okay? So a, if we dot this one, a dot b prime, i-multiply lang natin no? Nakoy, I have summation of, by definition of a dot product, this is equal to a I prime b I prime. Sakto ba? Tama? Mo man yung definition sa dot product. Definition of that product. Okay. So, therefore, a prime dot b prime is just equal to kani multiply na ko ani. Tama? I-multiply na ko siya ana. Okay, so I have pila na kabuk summation? Tulo na. Summation of I, summation of j, and summation of k. So I have summation of I, summation of j, and summation of k. Okay, so giisa ra na ko no, pero tulo na ka summation ha. Summation in terms of I, summation in terms of j, and summation in terms of k. So kopyahon lang nako ni no, nakoy lambda ij, aj, and then I have lambda ik bk. Okay? Tama? Tama ra no? Lambda ij, aj, lambda ik, bk. Rearranging. Pwede na ako siya rearrange. I have ijk, lambda ij, lambda ik, ik, aj, bk. Now, natay katong orthogonality condition. Kadamdo mo, if i-rearrange na po na ako ni, I have summation of jk, kuha na ko ang summation of I, summation of I, lambda ij, lambda ik, nakoy aj, bk. And this one is just kani is the orthogonality condition, sakto ba? Which is equal to lambda j, not lambda but delta jk. Tama ba? Sakto ba? Delta jk. This is by orthogonality condition. Orthogonality condition. Tama ba? So nakoy summation of I, summation of ij, jk, ay imong summation, so therefore ang imong delta is nakoy jk. Okay? Nakoy jk. So therefore, si A dot B is equal to, ang nabilin nga summation is jk na lang, nakoy jk, kay ang summation sa I kay nana siya sa katong orthogonality condition, jk coordinate delta of jk ej bk. Now, sa summation, take note, si jk, delta jk has a value, delta jk has a value of 1 when j is equal to k, and 0 when j is not equal to k. So therefore, sa summation, kung ang j nimo is not equal to k, then mag-0 lang na sa imong summation. Okay, nakuha. Mag-0 lang na sa imong summation. So it will vanish when j is equal to k. So ang mabilin nga term sa imong summation is when j is equal to k. So therefore, the summation now, maisa na lang imong summation in terms of j na lang. Tama? because this one, the Kronecker delta is equal to 1 when j is equal to k. So nakoy 1 siya, may mo siyang 1. So j now is equal to k. Tama? So dapat equal ning imuhang j o k para dili siya mag-vanish sa imuhang summation. Okay? Nakuha. And what is this? This is just the definition of a dot product of A dot B. As you notice, this one is the summation of AJ BJ, summation of in terms of J. And what is this? This is the definition of dot A dot B. So we prove that A prime dot B prime is just equal to A dot V. So the scalar product is invariant, equal lang sila, invariant. So therefore, the scalar product, ang yang product is a scalar quantity. Okay? So that's for scalar quantity. Questions ade, no? Napa mo dira? Napa siguro mo, no? Napa siguro? Sige. Walay question, no? Okay ra? Now let's move to a vector product. Okay. Again, we defined E1, E2, E3 as a unit vector. So, ikaw lang isulat na ako, no? Unit vectors. I have E1, E2, and E3. So, I have E1, E2, and E3. If this is my vector A, which has components A1, A2, and A3, okay, you can actually write this as vector A as A1, E1 plus A2, E2 plus A3, E3. So, from this, pasulat, pwede gyapon na ko ni masulat ang akong vector A as summation of AI's, EI's. Okay? So, pwede gyapon ako siya masulat as, in terms of unit vectors, I can write vector A as a summation of AI and EI. We can obtain the components. The components, makuha na ko ang components if dot product, if I get the dot product of AI and our vector A. Okay, so these are the components AIs, and masulat or masolve nimo ang mga components using these equations na koy EIs, the unit vectors dotted with the vector A. Okay, dotted with the vector A. Okay, and we also have this orthogonality conditions. It says that AI dotted with EJ, okay, is equal to Kronecker delta of IJ. Tama? Because in Cartesian coordinates, mutually perpendicular ang imong mga axis. Imong I hat, J hat, and K hat are mutually perpendicular. So therefore, if you dot product, say I hat, EI dot EJ, then mag-1 lang siya kung parehas ang iyahang index, and mag-0 siya kung di parehas. Like I hat dot J hat is 0, I hat dot I hat is 1, J hat dot J hat is 1, and so on. So nakoy, if kung magamit kong E1, E2, so nakoy E1 dot E1 is equal to 1, while E1 dot E2 is equal to 0. Okay? So that's the unit vector. Also, we have this for the dot product. We also have this definition of a dot product, A dot B, which is equal to AB cosine of theta. Sakto? Or you can also write this as AB cosine of AB. Unsa kaning basta kaning ingani kaning na close parenthesis kani siya. Okay? Is the angle between A, vector A, and vector B. Okay? So, pwede na ko siya masulat ang theta into parenthesis A and B. Para di ta maglibog later, no? Nga, unsa ni siya nga angle akong gamiton dapat. Okay. So, next to scalar product, so nakaiduha, no? Next to scalar product or edad product na tayo gitawag nga vector product. So, diri na ta mag-start o gamit atong Lebesgue-Civita symbol. Vector product. Sometimes we call this one as cross product. Okay, this is a definition of a vector product. C, another vector C, is equal to the cross product of two vectors A and B. So this is by definition. C is equal to take note ang result sa vector product is also a vector quantity. So nakoy C is equal to A cross B. Okay? Two vectors ako ang gikuha og cross product. The components, okay? We have this definition, take note. Okay? The components can be written. The components of C are defined by the relation Ci's, okay? Ci's is equal to the summation of duha ka summation, summation in terms of J and summation in terms of K. Take note, giisa lang ako, pero you can write this as summation of J, summation in terms of J, summation in terms of K. Okay? Epsilon I J K EJ B BK. Sa una, sayon naman to, no? Magkuha og components, mugamit lang ko og determinants, tama ba? Magkuha lang kog determinants, no? The components, as you notice, makuha nimo ang components niya as I hat. Ako lang i-compare, no? Compare lang nako. Nako AX, AY, AZ, and then BX, BY, BZ. Then get the determinants, makuha nimo ang mga components along I hat, J hat, and K hat. But now we will introduce another notation for components, which is equal to this equation here. Lisod siya lang taon, pero sayon naman sayon na sa gamiton later. Okay, take note, ha. Kung kuhaon nimo ang component CI, okay, kung kuhaon nimo ang component CI, then the EIJK, this EIJK is called the permutation symbol. Permutation symbol, or sometimes we call this one as Lebesgue-Civita density or Lebesgue-Civita symbol. Okay. Take note, kung ay imo hanggang kuhaon nga components, okay? Kung ay akong kuhaon nga components, ay notice ang summation is not in terms of I. Take note, kung ay imo kuhaon nga notation, ang summation is not in terms of I, but the summation is in terms of another indices, duha ka buok indices, say I call that one as J and K. Pwede ka magamit og L, M, any letter sa alphabet. Basta dili ka magamit og I. Any letter, duha ka any letter, muna imong ibutang sa imong summation. Nakuha. So nakoy CI is equal to summation of any letter, duha ka buok, J or K ba ka, summation of that, and then we have this Lebesgue-Civita symbol, epsilon IJK. Dapat maguna ang I, okay? Dapat maguna ang I. And then we have J and K, the indices of A and B, because C is equal to A cross B. Then ako'y J, and then maguna si J sa A, and then ang last is kaning K sa imuhang B. Okay? So this is the notation for the components of our vector product A cross B, or this so-called vector C. Now, what is this epsilon IJK? So dito na rin ta, no? epsilon ijk, same siya sa Kronecker delta, nga ang iyang value is, sa Kronecker delta, ang value na is 0 or 1, but ang Levi Chibita is nakoy tulo ka value. It's either 0, 1, or negative 1. Nakuha. Nakoy EIJK, tulo ka bukyang value. EIJK is tulo yang value. Pwede siya ma-0. Okay? Pwede siya ma-positive 1 and pwede siya ma-negative 1. Okay? So, kano sa ma-0 ang EIJK, ma-0 lang siya if any index is equal to any other index, to any other index. Okay, so kung may kog E112, then this one is equal to 0. Kaya na may kaparehas, no? Kung mag-equal na ay kaparehas, kung nagay parehas, then automatic 0 imong epsilon ijk. Nakuha. So E222, this is also equal to 0. E131, this is also equal to 0. Nakuha. Basta if any index is equal to any other index, then EIJK is equal to 0. Kano sa siya mag-1? If 1 siya, if IJK form an even permutation. What do you mean by even permutation? Even permutation of 1, 2, 3. So, ano meaning sa even permutation? Kano sa mga positive 1 kung mag-form mong IJK into even permutation. This is even permutation. Epsilon 1, 2, 3. This is epsilon 2, 3, 1. And this is epsilon 3, 1, 2. And this is equal to 1. So, lang taon mo ang kuha na. Nakoy 1, 2, 3. Kung ang iyahang form is padulong dira. Okay? Kana? Nakoy 1, 2, 3, 2, 3, 1, 3, 1, 2. Then that the Levi Chibita is equal to positive 1. Okay? Nakuha. When negative 1 siya, if IJK form an odd permutation of 1, 2, and 3. So nakoy nga ni. Kung imuhang pagsulat is pa counterclockwise. Okay, pa counterclockwise. Say nakoy 1, 3, 2, 3, 2, 1, and 2, 1, 3. This is equal to negative 1. Okay? Tanawa lang ang yang kaning padulong imuhang 1, 2, 3, 3, 2, 1, and so on. Kung pa clockwise, then positive. Pa counterclockwise, it's negative. 1, 3, 2, 3, 2, 1, and 2, 1, 3 is minus 1. While 1, 2, 3, 2, 3, 1, and 3, 1, 2, the Levi Chibita symbol is positive 1. We also have this. I, J, not I hat. I, J, K. Kung padulong gali dira, okay? Kung pa clockwise imuhang form, then that is equal to positive 1. So nako EIJK is equal to EJKI is equal to E or epsilon KIJ, then this is equal to positive 1. While kung pabalipod, okay, epsilon say IKJ, ako'y epsilon KJI, and epsilon JIK, this one is negative 1. Okay, so we'll now use the concept of the components of our vector products to solve some vector quantities like this. How will you prove? Saan ako pag-prove ng, so for example, prove that A dotted with B cross D. Take note na combine na nako gitawag na triple product, na ba? Combine na nako ang dot product ug ang cross product. A dot B cross D is equal to D dot A cross B. Again, these are vectors, okay? A, B, D are vectors. So prove that A dot B cross D is equal to D dot A cross B. Using kaning Levi, using the Levi-Civita symbol. Okay. Sayo na ba ni? Nakatry na ba mo ani? Hello? Nakatry na mo ani? Mugamit o Levi-Civita?
Wala pa, sir.
Wala, sir.
Wala pa. Tumayo, no? So, lang tao na to, no? Sa una, mugamit ta og components method. I-expand ako ning B cross D using katong determinants. Then, i-dot product na ako sa A. And then, rearrange such that mo conform siya aning A cross B dotted with D and so on. Mugamit ta atong mga AX, AY, AC, right? But, using Levi-Civita, dali lang niya solve. Okay? As long as kabalo ka sa concept of that product and sa concept of the components of a cross product. Okay? So, take note ha, ang components sa cross product is kani. Okay to? Kani ha? The CIs is equal to the Levi-Civita EIJK, AJ, BK. Okay? Now, proof. Solution. Proof there. Okay, let's start from here. And then, mupadulong taning kaning sa right na tong equation, or right equation. So mag-start na diri, no? A, i-dot na ko siya sa B cross D. Now, kabalo ko nga ang definition ni dot product is this. A dot some vector B cross D is equal to summation of AI and then B cross D I component. Tama ba? Sakto ba? Muna ang definition sa dot product, no? Na ko A dot B is equal to summation of AI BI. So therefore, na ko AI sa kon, tapos na ko I component sa B cross D na ako. Tama ba? So na ko summation of AI times the I component of my B cross D. Aha. Kani, kabalo ko ani, no? Kabalo ko ani. Kabalo ba ko ani? Kabalo ko ani, no? The I component of a cross product can be written in terms of a summation katong na terms of Levi-Civita nga symbol. Okay? So, note that B cross D, the I component of B cross D is a summation of some dummy variables JK. Okay, di ko magamit og ha, any letter JK, epsilon I JK, mag-una si B, no? B, tapos D, DK. Okay? Take note ha. Tama ba? Na ko EI JK, okay? BJ and then DK. So, pwede na ko sulat C A dot B. So, now we can write A dot B cross D as a summation of AI, okay? And then, unsa kay itong B cross DI, na ko summation sa JK of epsilon I JK BJ D DK. Okay, so na pila ka buok ang summation? Tulo ka buok, no? Nako tulo ka summation. Summation of I, summation sa J, summation sa K. So pwede na ko lang siya sulat as isa lang ka summation. Summation of I J K epsilon I J K EI, okay, and the DK. Nakuha. Okay ra, no? Sakto na, no? EI epsilon I J K, and then we have this indices sa akong A, B, and D. Ang ato ang goal is ipauna na to si D, ipagawas na ko si D, no? Ang goal na to is ipagawas na ko si D. So pwede na ko isulat, i-rearrange na ko ang ABD as this one. Epsilon I JK. Isulat na ko si D una, no? DK DAB ang iyahang form. So na ko DAB. Pero wala na ko i-change ang indices niya, ha. Ako lang commutative ang number, so pwede na ako i-rearrange ang kaning mga ABD. Pero ang dami indices I ang index sa A is AI ra gina siya, no? But ako lang i-arrange para somewhat kabalo ko nga para somewhat makuha na to ni siya nga term dira D cross AB. Now, si EIJK, okay, ako butang diri ha. Si epsilon IJK kay equal lang mo ni siya ni epsilon JIK, sakto ba? Tama ba? Which is equal to positive 1. Sakto? Kani? Kani epsilon IJK is just equal to epsilon KIJ. Okay? KIJ. So pwede JIK dahil, sorry. Not JIK but KIJ, sorry. KIJ dahil isa. So na ko K I J. Somewhat i-relate na to siya ani K I J. So walay negative nga mahita, walay negative na ko nga idungag, it's positive lang gyapon. So you can rewrite this. Pwede na ko masulat ang AIJK into epsilon K I J. Nakuha. Nalain ko yung nga form. Epsilon KIJ, DKAI, and then BJ. We have rearranging. Isulat na ko sa gawas ang K. Summation sa K. Okay. DK. And then, ang sinabilin nga summation, do kabuok, I and J. Epsilon KIJ AI BJ. Okay? Sakto ba? Gi-rearrange na ako, no? Gi-rearrange na ako ang ipagawas na ako ang DK, summation sa DK, and then the summation of IJ na nabilin, and then epsilon KIJ. Notice, take note, unsa ito, kung ang summation is IJ lang, and then sa imong epsilon, ang nagunang index is K, then this one, this term here, this is the definition of the components of the cross product of AB, the kth component. Kth component man no, kay wala man sila abot sa imong summation. So mura na nang timan-an ang pinakauna nga index sa imong epsilon, muna ang imong i-component sa imong cross product. Okay? So that one is this summation. This summation is the kth component of the cross product of A cross B. So therefore, masulat na ko siya ani. Summation of K. K. DK. A cross B of K. And what is this? This is the definition. This is just a definition of a dot product. Since same sila og index, K, 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 then this is just equal to the dot product of D and A cross B. So therefore, we prove that A cross B is equal to D dot A cross B. Okay, using Levi-Civita symbol. Nakuha. Okay ra? Okay ra ba? O dili? Makaya ra? Pera no? Saan naman siya, no? Walay question? Wala ra?
Done, sir. Headpan naman.
Okay. Okay. So I think there are siguro tataman. There are tataman.
Sir, dili
Later,
may
next week.
ka-access.
Yes?
Sir, dili may ka-access sa video nga imong gi-post, sir.
Kinahanglan nito ikuan i-sharing din I think i-share na nako gay na sa inyo.
Okay, sir. Thank you, sir.
Ah. A cross B cross C is equal to B A dot C minus C A dot B using the Levi-Civita symbol. We are going to prove also this term. Show that A cross B that na question is C cross D. We'll prove this one later. AC BD minus BC A dot DT. We will prove this one. So na another important property. Kani bitang mahimo siyang two terms na important property ani. I will discuss this later. But your assignment, I will give you an assignment, not assignment but sheet work to be submitted today. Okay? Your assignment will be this one. Show. Not assignment but sheet work. Sheet work using Levi-Civita. Okay? Sheet work number 1. Kanang sayon lang, no? Ngita ta dere. Bisa. Kani.
Class, taman mo tennis Sir Rowel karon?
Dili. Malamig klase man. Okay, i-post na nako unya siguro, no? I-post na ko na. Mangita ko ng sayon-sayon ra nga sheet work para sa inyo, ha. About proving vector quantities, triple scalar, triple products using Levi-Civita symbol. Okay, so attendance.
Sir.
Ano na ko, ha? Oromo, Aquino, Kimno, Galos, Yelpis. Murag may absent. 15 man 13 man makabuok, no? Okay, wala absent. Okay. Wala absent. All are present. August 20, no? August 20. Okay. So, any question? Again, i-post na ko ang sheet work later. Makita ko sayon lang nga problem para deadline is today, okay? Anytime today. Okay, question wala. See you next meeting. Bye-bye.
Thank you, sir.
Thank you, sir. Bye.